They say the CPU is the brain of your computer. Well, if that's true, then the GPU is the muscle. Let's see how it flexes. First, let's get physical. The large block you hold is the graphics card. It plugs directly into the motherboard via the PCX16 lanes, usually the long slot closest to your CPU. That specific spot provides the massive bandwidth needed for the card to talk to the rest of your system. Once it's plugged in, what's actually happening inside? Underneath the fans and heat sinks is the GPU die itself. Unlike your main CPU, which is like a genius professor solving hard problems one at a time, the GPU is designed as an army of thousands of tiny workers. This structure is called parallel processing, and it drives the three main use cases of this technology. The first, of course, is gaming. A modern game requires calculating the color and lighting of millions of pixels, 60 times a second. The GPU's army splits this load, painting the screen instantly. To do this, it uses VRAM, those black chips surrounding the processor, to store textures and game maps for quick access. The second use case is content creation. If you edit video or render 3D animation, the GPU takes the heavy math of rendering effects off the CPU, speeding up export times from hours to minutes. And finally, the new frontier, artificial intelligence. It turns out that the same army of workers approach used to render pixels is perfect for training AI models. The GPU runs billions of small calculations simultaneously, which is why they are the engine behind the AI revolution. So, whether you are slotting it into that PCI lane for fragging enemies, rendering a movie, or training a neural network, the GPU is the ultimate brute force. Either way, which team are you? Team green or red? Comment down below.